Welcome to this training video for steel detailers on how to go ahead and set up a project. This video is going to be broken into two major parts. The first part is actually looking at the scope as well as the design and specifications to make sure that you have all the information to do the job. And then the second half, or part two, is going to essentially be looking at what are the different questions and information that you need from the fabricator in order to successfully detail the project. Now here are some images from the 3D model of the project we're actually going to showcase a little bit here. It's a pretty basic structural floor framing model where there's a garage at the basement, and then there's the first floor framing where the structural steel is at. And the exterior here is basically a 12-inch cast-in-place concrete wall. So we have some bracing and beams that are framing into that, and then there are a couple of interior openings for stairs as well as an elevator shaft that we're going to have some beam framing and embeds that we're going to have to work with. Now, what are some of the things that you need before you actually start the job? The first thing you of course need is the design drawings, and you at a absolute minimum need the structural drawings or the S series drawings, and then you'll also typically need the architectural or A drawings. Now, along with that, oftentimes you'll see a series of specifications that come along with the project. If the fabricator has this, it'd be great to get that because there are often clarifications on paint or certain material grades and fireproofing, and even certain inspections that are sometimes in the specifications, and you want to correlate that with the design drawings. Then next thing you want to get is a scope sheet. Before you start a job, the fabricator during their estimating process, and even when they're asking us to estimate the detailing on the project, is going to typically have a scope sheet. Now, they're usually going to list all of the inclusions, and they'll reference design drawings as well as specific details where steel items are shown. And they'll oftentimes also include an exclusions list. So things that are specifically outside of their scope that we want to watch out for and make sure that we don't accidentally detail. Now, we're going to then take that, and then we also need to validate based on that scope sheet what's going to be delegated connection design potentially by us or a connection engineer that we hire or that the fabricator is hired versus what the engineer of record is actually fully designing on the design drawings. Then we also want to get a BIM execution plan if that's applicable on the job. If there's specific types of file formats or base points or origin points or rotation of how the building needs to be modeled in coordination with the BIM execution and for the contractor to coordinate with other trades, we'd like to understand this. If we're taking the architect or the engineer's model and we're supposed to be using that to expedite detailing, what are the contract requirements of that? And does the design drawings govern versus the models, or can we depend on the models? Those are things that we want to understand from a BIM execution plan. Then we want to get the fabricator detailing standards, and this is really important so that way we can understand how shop drawings need to look, if there's a specific piece marking strategy that's involved, how they want to do basically their title blocks, if there are standard details and things or standard RFIs that they'd like to propose. These are things that we want to understand from their detailing standards. And then lastly, and really importantly, is the schedule with key milestones. So understanding all the deliverables that we're expected to produce on the job and when. Is the job going to be one big submittal, or is it going to be broken down by different sequences or phases and different submittal packages? Do we need to get the advanced bill of material out, or do we need to get the anchor bolt and embeds done first? How many hours are actually allocated on the job? As a lead detailer, you definitely want to understand, what did the estimating department give you as far as hours? Look at the breakdowns on the scope and the estimate. And then as you study the job and you get a feel for exactly how you're going to detail it, do the hours match up? And as you go through each one of these milestones on the job, you want to periodically check in and just see exactly how many hours you have used to see if you're on track. And then also you just want to make sure that you can see exactly how much checking time that you're going to need and what percentage of that is going to actually be used for your hours versus just straight production detailing time. One of the most important things that I want you to take away from this video is that you should know how exactly you're going to do the job before you put anything in the model or you draw anything on your drawings. And the whole concept here is that if you do good prep work, and it is going to feel like you're spending a little bit of extra hours on the front end, but a lot of hours that are put on the front end are going to save you from having to rework or redo things and fix errors later on in the job, especially when it comes to finding information, asking all the right questions, and knowing exactly how the job's going to flow. Oftentimes, I'll see people just get started with the model, to start modeling in sticks because they're in a hurry, they're trying to get things going. And then what ends up happening is they have to come back later and fix things, and they get marked up on during the checking process, which again just eats hours into your job, and you have to come back and do rework that you could have prevented. Now, in order for you to know exactly how the job's going to go before you start doing anything, you need to thoroughly study the design and make sure that there aren't any RFIs that you need to ask or requests for information. Now, you want to find as many of these questions like missing information or clarifications that need to be identified as soon as possible, and you want to actually submit those questions and RFIs in a priority order of how you want them answered. So basically, as you see me step through some of these slides and some of these examples, you'll see that I'm doing it in the order in which I have my key milestones or deliverables on the project. If I'm doing an advanced bill of material and that's the first thing I need to get out the door, then I'm going to start writing all the questions and RFIs that I have on dimensions, profile sizes, or the geometry and framing on the plans, because that affects the advanced bill. If I'm looking at anchor bolts and embeds, then I'm going to be looking for those details, top of footing and bottom of base plate elevations, and any missing information on the anchor rod design, and I'm going to get those RFIs out the door as soon as possible. So group your RFIs based on the priority order and the different condition that you're trying to work on and get answers on first. And you want to get the RFIs out as soon as possible, because just imagine that it might take a few days or a week or even longer in some cases to get those RFIs. When you're working with your customer, the fabricator, you want to clue them into the missing information and really kind of the feel for the job. If there's a lot of RFIs and a lot of clarifications that are needed, that's going to potentially clue into you and them that, hey, this might impact the schedule. You want to know this as soon as possible. You don't want to be waiting 2 weeks into the job and then you all of a sudden have a connection RFI and the fabricator says, hey, why didn't you ask me that 2 weeks ago? We could have gotten you that information and it wouldn't have impacted potentially the schedule. So find the RFIs as soon as possible and group them and submit them in the priority order based on the things that you're doing on your schedule. So what are some of the things that you want to find in the design drawings and the specifications? First thing you're going to do is you're going to go through the scope sheet from the fabricator as well as our detailing estimate, and you're going to go through each of the design drawings and highlight off whether you found everything. And if there were specific exclusions, then mark those up as well. So when you pass it to the checker or other detailers on the project, it's very clear exactly what they do need to do versus not include on the project. Then you're going to look at material grades. Are there multiple material grades for plate, such as A572 as well as A36 on the job? Is it clearly designated and understood where one versus the other needs to be used? Is there 65 KSI material required for HSS or grade C? These are all important things to make sure you understand, because they may impact whether you can get your advanced bill of material out to the fabricator, and you want to make sure that these are correctly noted at that stage. Then looking at bolt grades and diameters. Oftentimes you'll see as a starting point on jobs that 3/4 inch A325 end bolts are most typically specified. Sometimes you'll see higher strength A490 bolts used. And then sometimes you'll see instead of the N designation, which stands for threads are included in the shear plane of the bolt of the connecting parts, sometimes you'll see SC for slip critical, which will affect potentially no paint areas. And then X, which means threads excluded from the shear plane. If you ever see these kind of conditions, then coordinate with the fabricator or another lead detailer to see exactly how this impacts your job. Then you have paint and clean specs. I almost always ask the fabricator about this. Sometimes you'll see on the design drawings or the specifications that a paint primer or a clean spec has been specified, as well as what fireproofing on certain areas or galvanizing. At any case, even if I see this on the design drawings, I almost always go back and talk with the fabricator about this, making sure that we both agree on what the scope is and which areas require paint versus no paint. If there's any AESS specified, which stands for Architecturally Exposed Structural Steel, if there's any requirements as far as that goes, because there are different levels of that, I again always go back to the fabricator to find out exactly how they want me to note things on drawings and to make sure that we both agree on the scope and the spec required for that. Next thing I'm looking for is, and really this is critical again to the advanced bill of material, and you want to find this at early stages of modeling where you're putting in the grids and the main framing. But you want to check if all the elevations are shown. You want to make sure that all the beams are dimensioned and pieces are located on the drawings. And then also verifying profile sizes. Again, this impacts your advanced bill of material. And basically, if your framing is wrong or there's missing information on the framing, you can't do connections or the next phases of the project. So this is the first area to really start looking for RFIs. Then looking for any conflicts. Are there any callouts that are different between the design drawings versus the specs? Or are there dimensions and certain information shown differently between the architectural versus structural drawings? If so, then you're going to want to go ahead and get clarifications or potentially write RFIs. Then the next big phase is really going through each one of the sections in details and clearly differentiating what's the scope between the engineer records connection design versus delegated connection design that might be done by a connection engineer hired either by us as the detailing firm or the fabricator, making sure we have a clear understanding of the differences in scope on that. If the engineer record is involved and responsible for the connection design, then is there any missing welds, material sizes, or does the detail that's actually shown, is it just a standard detail and doesn't fit specific geometry or conditions in the model? CP welds and moment connections, this is also a big deal. Oftentimes we see mostly welded moment connections where the flanges are complete penetration welded. We want to talk to the fabricator and the erector about their specifications. Do they want a certain root opening or a groove bevel side? How do they want their rat holes? Are backing bars going to be removed in the field? If so, if that's a requirement on the specs, then do we use ceramic backing bars, etc.? And then you're going to closely during kickoff kind of want to talk to the shop about what's going to be shop versus field welds. And so, the fabricator wants, especially if it's a fabricator and erector together, they're going to want to eliminate as much field work as possible and combine things where they can. So you want to kind of quickly go through, if there's not obvious conditions, what's shop versus field welded. And then you want to take a look at if there's any special seismic or material testing requirements and notes that need to be put on welding symbols or in the bill of material that's required. CVN is a pretty common one, Sharpie V-notch. You'll see that as a testing requirement. And so you just want to make sure you keep an eye out for that, especially in the specifications as well as the general structural notes. Then you're going to be looking for any conflicting or unclear information. Sometimes you'll see sections and details where one detail or one section tells you to refer to another one, and then you see two different dimensions or plate thicknesses or callouts from one to the other. And so then if that's not clear, then you're going to want to go ahead and write an RFI and get a clarification. Then the last thing is that as a good detailing practice, as a lead detailer, as you're going through the job and you're sort of marking up different things to point out to your detailer and your checker, you're going to also want to start to map out which component or connection are you going to actually use. So if you're in Tekla, you're going to be figuring out which connection number, or do you need a custom component, or is that going to need to be manually done? And you as the lead, you're the one who knows how to use the software in the system better than some of the others. And so you're sort of setting a guide or creating that example and sort of thinking ahead. If there are certain connection types that you know that the software doesn't do, or you don't know how to do that in the software, identifying those and then talking to the technical administrator for your team and giving them a heads up of, hey, these are different custom components that I might need, or we have like a lot of these conditions and there's not something out of the box to do that. Can you set something up for us? Same thing over if you're doing a job in STS2. If the automatic connection design or connections don't do that on the member ends, and we need a parametric or we need some standard assemblies to go ahead and put some basic building blocks in and manually model those, then just clearly identifying those on the drawings early during the review process helps the technical administrator find out exactly what they need to do to help you earlier on the project. All right, so let's actually start taking a look at some of the design drawings and walking through some of those items we just covered. First thing here on the structural notes, I'm actually looking for welding specification. I can see here it talks about getting the delegated connection design stamped by an engineer registered in the state that the job is in. I can see material grade callouts, the A992, the A500 grade B, and then the bolt diameter. And then here there's actually an example of the shop code of standard grade primer. And so this is something I just asked right away to the fabricator in an RFI and during the project kickoff. And they actually came back and told me that any paint is actually outside of their scope. Then looking at the anchor bolt grades, F15, 54, A36 is pretty common. Sometimes you'll see a grade 50 or a higher KSI that's required, so you want to keep an eye out for that. All right, then I move over into the foundation plans because I'm starting to look at getting the anchor bolts and the embeds out for approval first on the project. So I'm looking at the foundation plan, and really first what I'm looking for is the column sizes and the elevations for the top of footing or the bottom of base plate. And so here what I can see is that there's actually a column schedule and footing schedule, as well as an elevation that's noted here. And then there's even a typical detail that's called out. And then I can also see the top of slab reference elevation at this foundation. Now the reason why I care about that is because I actually usually create my anchor bolt plan at that elevation in the model, and then I base the footings and the bottom of base plates from that as a reference oftentimes. Now, so I see the C11 and the F7, so I go over to the column schedule and the footing schedule, and the elevation shown was to the bottom of footing, so I actually had to derive the column or the footing thickness for this F7 footing. That got me to the top of footing, and then I went and looked at the section in detail to figure out the grout and what I needed in order to get to the bottom of base plate for the column. So when we start to move over to that in the foundation details, take a look at this for a second and pause the video if you don't mind, and actually look at both the details and see if there's anything in here that's missing. Do you have everything that you need in order to completely detail this correctly? And is there anything that might be questioned or open in your mind? So pause it and go ahead and start writing just a quick list to see if there's anything that you can identify. Now, some of the things that I found were the engineer did specify a 1'3" long anchor rod or anchor bolt, and they did give me the projection, but they didn't really clarify whether or not this 1'3" was for the embedment or if it's the embedment and the projection combined together. Is the hook considered in there, and what is the hook size? So these are things that I needed to get clarified. So what we ended up doing is we detailed the job, assuming 1'3" minus the 4" projection, which gave me the 11" embedment. But then even when I went back and I compared that to some of the footings that I modeled, with 11" embedment, the anchor rod was actually too deep on the footing and was too close to the bottom of the footing or even extending beyond the bottom of the footing. So I asked an RFI to get this information clarified. Now, some other things here that I noticed is that the engineer sized the holes on the base plates. Oftentimes I don't see this. Basically, you're following the AREC manual and the standards, and it was pretty common tradition or practice to do 5/16 oversize. Now, in some of the newer editions of the AREC manual, you can actually go bigger than that, but when you start going bigger than these diameters, you have to start looking at whether or not you're going to use plate washers there. And then sometimes those plate washers actually have to be welded to the top of the base plate. If you start adding plate washers there to cover those oversized holes, then what starts to happen is maybe the actual spread and spacing on the anchor bolt starts to increase, which then impacts the design. So these are really important things to make sure you understand and get clarified with the fabricator, and just kind of let them know exactly what you're doing and see if that fits what they want in the field. Now, another thing here over on the left is whether or not you're using shims, like to put underneath the grout and the base plate to hold it in place, or if you're going to put leveling nuts. Here, if we were using leveling nuts underneath the base plate with the template, this 3/4 inch grout would not be enough for these bolts. It's hard to get any kind of access underneath there to adjust the elevation if required after the column's in place. So oftentimes we'll ask for increasing that grout size to be like 1.5 inches at a minimum, or a little bit bigger depending on the diameter. So those are some of the things that you want to take a look at here on base plates. One last thing is that on this specific job, there was a HSS 6x6 column also called out, and there was no detail shown for that. So there was a 5x5 and an 8x8 detail shown, but nothing for 6x6s on the actual job where I had some 6x6 columns. So I used the 8x8 detail, and then I just said approve or verify, and we wrote an RFI as well to get clarification. So this next one happens to me pretty often. I'll see that there's a standard section or detail that shows one-dimensional thing that's different than what's actually called out on the plans. And so here I had a typical interior column section that showed a bottom of base plate elevation of 1/16 foot 8.5. But when I actually go back to the plans, look at the footing schedule and everything, when I derive the elevation, it comes out to 1/16 foot 1 pretty much everywhere on the job. Now, the dimensions were close enough to where I was like, hey, this isn't just something that was forgotten to be edited potentially on the section, on the design drawings, and I felt like, hey, I need to get clarification and write an RFI on this. Now, I did go ahead and go with the 1/16 one and asked to get that verified because if you see here on the section in detail, there's a lot of C-plan for bottom of footing and references back to the plans to get more information. So we went with the 1/16 one and just asked the engineer to clarify that. Now, one other thing that you'll see here is that there's actually this encased column, hot dip galvanized, and it's only a certain height. And so I asked the fabricator, hey, are we going to actually use like this waterproofing paint? And is there standard primer on the rest of the column? And again, just writing a good RFI on this, found that this was excluded from their scope, and there is no paint and just standard clean for the structural steel. All right, the next area of focus was looking at the structural plans. So the very first thing I start looking for is the top of steel elevation. Sometimes the engineer won't actually specify the top of steel. They'll specify the top of concrete, or they'll even reference you back to the architectural drawings to find out the top of concrete elevation. And then what they'll tell you here is the deck span direction, as well as what the slab is comprised of. So they'll tell you the deck thickness and the overall concrete, and then give you the total depth. So in this case, it was 5 1/4. So if the engineer doesn't specify the top of concrete or the top of steel, you'll usually see this, and then you can go to the architecturals and derive the top of steel from that information. Now, the next one that's really important to understand as a detailer is you'll see sometimes in the structural notes or on the plan notes, verify all dimensions are indicated with the architectural drawings. So, the engineer may even fully dimension something, like here you can see at the lower right, the 9'5" dimension that locates a beam. But he's locating this based on coordinating with the architect as far as the column that's going above it. Now, as a practice as a detailer, I like to say that, hey, the structural engineer should be coordinating with the architect to do design coordination. So that means the engineer is locating and sizing pieces in coordination with the architect based on the design and requirements that are needed. So I'm depending on the structural engineer to tell me exactly where and what sizes of pieces are being located for his frame. And now what I'll oftentimes do is I will then just go ahead and give my best guess or a scale. Sometimes I'll reference the PDF actually in my model, and if it's to scale, I'll locate beams if they're not obviously centered or called out by the engineer to be centered in a bay. And I'll locate things there, but I'll put those on hold, or I'll add an extra 12 inches or something like that to the material length for an advanced bill, and I'll tell the fabricator that as a note. But then I'll also ask the fabricator whether or not we should say approve or please provide, or verify the dimensions out for approval. And I'll also ask them, do you want me to write RFIs locating these beams? Now, oftentimes the fabricator will tell me, hey, please don't write 50 million RFIs locating every beam. So they'll ask me floor by floor or by a general region or area to put the dimensions based on my best guess, or cloud up the areas that are missing, and then submit an RFI for that whole area, asking the engineer to locate those beams or verify those dimensions. Now on this job, we had both a delegated connection design, so a connection engineer, in this case Rexconn Design, our engineering firm, did the connection design for a certain scope of the shear connections. And so the engineer did put end reactions for most of the beams. And then there was a typical note here that if it was not noted, then to assume for 12 kip reaction. Now, this is really good to understand because sometimes the end reactions are not shown. And sometimes it's not just saying, hey, use this 12 kip reaction. Sometimes you'll see in the structural notes or in the plans that the engineer says design for 50% UDL or based on the maximum shear. So you want to watch out for these notes and just clearly identify wherever the engineer has put the reactions, or if they're saying that we need to derive the reactions based on the maximums for a certain member size. All right, so again here, just continuing on structural plans. In the image on the left, this was actually a framing condition scenario that I quickly saw that I was looking for as I was laying out the job in the model. And even before, I was trying to scan to see if I could find all these. Here, there was a very large W30 that was offset away from the grid line because of the framing at the south end of the beam. And it was put right halfway in between this CMU wall and then the column. So there was nothing on the design to figure out how to do that connection, and it's a pretty high end reaction there, so we had to RFI that. Then here you can see that the structural drawings didn't dimension the grids, nor did it dimension the layout and dimensions for a lot of the concrete wall. So what did I have to do there? I went back to the architectural drawings to find a lot of those dimensions for the grids and then even the wall dimensions. And then just as a note, sometimes you'll see this, the architect will put things in degrees, minutes, and seconds for the angle. And so there's online calculators, so you can quickly convert that to get to a angular degrees measurement, so that way you can easily lay out the grids. But again, I had to go to the architectural drawings to find a lot of this information. You'll oftentimes see a lot of structural engineers will do this during coordination, because they don't want to have during the design iteration process, they don't want to have differing information from the architect. So they'll leave some of this information off their drawings and say, go see architecturals for this, so that way they don't have any discrepancies. So the next thing here is looking at conflicting or unclear information. So I was working with an elevator shaft on a project, and at the foundation plan, it showed what looked like cast-in-place concrete on all four sides at the base. And there were dimensions that were provided. Now, when I actually look at the first floor framing plan where the steel was, I was trying to figure out how are the beams going to actually frame into that elevator shaft. At just purely looking at the plans, I was assuming that the CMU wall actually started down at the garage level below at 118 foot, and then here at the first floor level at 129 foot that I was actually going to be framing into CMU. Now, when I went back and took a look at the section cut there, I couldn't find that actual section cut on the design drawings. So I found something that was pretty close to it. When you actually look at this, the section cut looks backwards from what I think is actually happening. So you'll see that there's this elevated concrete, cast-in-place concrete wall, and then over here on the other side of the elevator shaft, it's shorter and only goes to the 118 foot. But over here, you can see that the wall goes actually to the 129 foot at the first floor. So when I started studying that and saw that the section looked like it might be backwards, the architecturals show that there's this thicker cast-in-place wall, which I think is this one. And so when I looked at that and compared it to the foundation plan, I was like, okay, looks like this wall goes higher than the rest. And so these beams here actually are going to be framing into pockets along this wall. And I at first didn't catch this. I actually almost missed this on the detailing, and I really had to study this here to make sure that I was interpreting it correctly. So what's really important to do is that when you get near elevator shafts or stair openings or stairwells in the project, really trying to make sure that you can completely understand from the sections and details and then the changes in the plans to make sure that the information it makes sense and it all correlates and works together. Now, one thing is I also saw a typical elevator shaft framing here. And a couple of things to note on that is that the clear opening dimensions were shown, and then those were different than what I actually saw on the foundation plan. So I needed to get those clarified. And then also going back to the scope, I saw that there was this hoist beam and an HSS called out here, but this was excluded from the scope. And so we needed to go back and look at that fabricator scope to make sure that we did not include that. All right, so next we started taking a look at the embed details, because that was the next thing on the scope that we needed to get out after the anchor bolts and the advanced bill. And so when we started looking at this, if you look at the detail on the left, you see that I've tagged this as EOR. So again, because there was some delegated connection design with our connection engineering firm versus some things done by the engineer record, I clearly marked out on the PDF drawings for my detailers and checker, so that way they knew which was which. Now in this case here, when you actually look at this detail, you'll see that there's some potentially missing information or things that we need to get clarified to finish this. The first thing I identified was that the engineer did size the plate, and he did tell me that he needs 2 3/4 inch diameter studs, but he didn't specify the length. And so I assumed 4 inches based on another detail or a similar condition I saw somewhere else on the job, but I wrote an RFI and did say approve or verify on the approval drawings. Now, there is an 8-inch shelf called out there, but I don't know exactly how far over that the beam length needs to go into the face of the wall. So I went with 7 inches based on what I saw in the detail there visually, and I saw that there was a 1-inch buffer material that was required at the end. So I put 7 inches and again asked the approver or engineer to verify that. The other thing is I didn't know actually what the pocket width was. So when I was trying to figure out the size or the length of the embed, because you can see here the engineer actually says varies based on different beam sizes. So what I did is I looked at and kind of scaled on the drawings where he draws a pocket actually on the plans. And I found that it was approximately 12 inches when I scaled it. And so I made it 12 inches and asked the engineer to verify that in an RFI and on the drawings. But then what I did too to simplify the quantities and the piece marks for the embeds is I looked at all of the beam sizes for the beams going into the wall, and I made the length of that embed the same. So I looked at the beam pocket, I looked at the minimum weld lap that might be needed there to get the beam to the embed weld, and the variance in the beams was not too large, and so I just made everything the same mark. Now, the advantage of this for the concrete contractors, they just get a truckload that gives them a pile of the same embeds everywhere, and then they just basically have to put them at the correct elevation. But they're not trying to figure out lots of different piece marks, one or two pieces, different pieces here and there. It's all the same mark, and they're just putting it at the correct elevation. Now, there was one condition here when you look at the job where there's these W21s and these other beams that are framing in the other direction. Now, you can't get pockets in there for all of those, so I wrote an RFI to the engineer saying, what are we supposed to do for these north-south beams, like the 8x10? Are we supposed to extend the W21s further into the wall in the pocket, deeper than that 8-inch shelf? And do we just frame the 8x10 and the other beam into those beams? And what should we basically do there? So I wrote an RFI, and this is one of those cases where there is a design detail showing the pocket condition, but there's specific geometry on the job and in the model that doesn't necessarily support what that connection design is called out for. So you ask an RFI to figure out exactly what you're supposed to do there. Now, continuing on with embeds here, because that was the next phase and scope of the project, there was this continuous bearing plate that was required to support the end of the deck. Now, what you'll see here is that the actual section that was called out, and if you look for the deck direction symbol, it showed that this detail was called out on the north and the south walls of the building, which is basically going to be perpendicular to the deck span. So that makes sense. Basically, the end of the deck or the lengths of the deck need to sit on something. And so here you can see there's this shelf that's been required, the 6-inch shelf, and then there's a continuous plate. Now, this is a very thin plate, and some of these lengths get really long, like 25 to 30 feet even in some cases. And so having that plate with the studs, I was worried about a person being, like the concrete contractor, being able to easily carry those, pick them up, and put them in place and accurately get them laid down inside the formwork to get a good location. So we talked to the fabricator and asked, is there a certain maximum length that we should use? And also to get more of the same piece mark in different locations across. So what we ended up doing is we said that, hey, let's just go ahead and make 10-foot maximum lengths. And then the last piece along that span will be kind of a unique length as long as it's smaller than that 10 foot. So that's pretty much what we did here. You can see the examples in red of where we actually put the embeds. Now, the question that came up is that, hey, is this embed only required at the end of the deck? Because in the section in detail, you can actually see here the deck is shown going the other direction, right? So this bearing embed is actually parallel to the deck. Now, that's likely just a standard detail, issue here or case, and I followed the plans. But it does pose a good question of, does there need to be some sort of pour stop or a slab and deck bearing edge here, or is that just going to be gauge metal that the deck manufacturer would provide? Since that wasn't clearly designated on the drawings, we just asked a fabricator through an RFI, and we're waiting to get that verified. So now I started to move into the structural steel connections. Once I got the anchor bolts and embeds all done, I wanted to start making sure that I had clear understanding of the scope between what our connection engineer was using through Rexconn versus what the engineer of record was doing, and making sure that the fabricator had clearly understood the same. Now you can see here, even in the same section in detail over on the left, 2 on S4, one part of the detail is done by the engineer record, so the cap plate where the beam is bearing over the column, and then basically Rexconn was doing the beam-to-beam connection there with those clip angles. So we I designated this on the PDF drawings so that way my checker completely understood that, as well as my detailers, so they knew where to go get the information and who was responsible. Then over on the right, this was interesting, is the fabricator actually wrote an initial RFI. Sometimes Rexconn or our connection engineer will actually do the bracing connection design. But because the engineer had actually sized welds and put some dimensional information here, the fabricator had decided that, hey, the EOR is going to go ahead and complete that detail and specify the rest of the information. So they wrote an RFI, but they missed a couple of the things that we wanted to get. And so we had to write a subsequent RFI that actually asked for additional information on the stiffener shown up in the beams. So again, this is, although you need to get framing and structural notes and paint questions out early, just as soon as possible, even before you actually start connecting the job, you want to get clarifications on connections and things early, because sometimes the turnaround on those takes a little bit longer than some of the other questions. And so the earlier you can get those RFIs and those clarifications out, the better, so that way you don't have to stop production when you're actually trying to apply the connections in the model. So here is another one of those cases where I just needed to look at the scope, talk to the connection engineer and the fabricator, and make sure I understood the clear distinction between what the EOR was responsible for versus what Rexconn, our connection engineer, was responsible for. So in this case here, any of the beams framing into the CMU walls at the interior openings, or any of the beam to concrete, pretty much the fabricator had designated that, hey, the engineer of record is responsible for that. And then the delegated connection design was limited here, for instance, to the shear connections from the steel to steel or beam to beam connections. All right, so now we start taking a look at the actual delegated connection design and what Rexconn provided us as the detailer, so that way we knew how to proceed with applying the connections. Now, if you look at the fabricator detailing manual and their standards, it actually tells you how they would prefer to do the connections for their shop as well as for the field, if the engineer record doesn't specify otherwise. Now here they said that for beam-to-beam connections, which was a majority of the job, they wanted shear plates, and then they wanted clip angles if they needed, stronger connections that single shear plate wouldn't work with. So Rexconn put together basically a connection detail, and then it gave me a chart, and it assigned marks to each one of those. Told me the beam size, all the dimensional things that I needed to look for, including cope size, distance from the face of connection to the holes, edge distances and things. And then basically as the detailer, my job was to go through and look at the end reactions that are shown on the plan, look at the beam sizes, look at the coping geometry that's formed between those two different beam sizes, and then apply the right connection. Now, I then checked the capacity that his connection marks were good for in his chart, and I verified that the end reactions shown on the drawings for those beam sizes and that geometry would work. So that's the detailing process here. I'm working with the Rexconn shear connection schedule. I find that, I check the geometry and the reactions, and then I apply the correct connection in the model. Now, once you've reviewed the design drawings, the specifications, and verified the scope, the next thing to do is to actually go through the detailing standards and start looking at the questions that you want to ask specifically to the fabricator and the erector. So take a look at what this section is going to cover in part 2 of this video series.